Let's construct the Lewis structure of PCl3, shorthand for phosphorus trichloride. Follow these simple steps to accurately draw the Lewis structure of PCl3. First, sketch a rough diagram of the structure. Next, illustrate the chemical bonds between the atoms. In the third step, determine how many lone pairs each atom will receive and mark them on the structure. Then, ensure that each atom in PCl3 satisfies the octet rule. Finally, calculate the formal charges for each atom to verify the stability of the final structure. To draw a rough sketch of the PCl3 Lewis structure, we first calculate the total number of valence electrons and then determine the central atom. The total number of valence electrons in PCl3 can be determined by summing the valence electrons of each atom in the molecule. Phosphorus, a group 15 element, has 5 valence electrons, while chlorine, a group 17 element, has 7 valence electrons. Since PCl3 contains 1 phosphorus atom and 3 chlorine atoms, the total number of valence electrons is calculated as 5 plus 7 multiplied by 3. This simplifies to 5 plus 21, which equals 26. Therefore, PCl3 has a total of 26 valence electrons. The central atom in PCl3 is the one with the lower electronegativity value. From the periodic table, we get the electronegativity value of phosphorus as 2.19 and the electronegativity value of chlorine as 3.16. Since phosphorus has a lower electronegativity, it is chosen as the central atom. Therefore, when drawing a rough diagram, place phosphorus in the center and arrange the 3 chlorine atoms around it. A single chemical bond is represented by 2 electrons. In this diagram, we will use 6 electrons to form 3 chemical bonds. Therefore, from the previously calculated total of 26 valence electrons, after using 6 electrons for these bonds, we are left with 20 unutilized electrons. Lone pairs consist of electron pairs that are not involved in chemical bonding. Remember that each lone pair contains 2 electrons. As discussed, we have a total of 20 electrons remaining that are not involved in chemical bonding. From these, we can form 10 electron pairs and mark them as lone pairs on the structure. It's important to remember that both phosphorus and chlorine are period 3 elements and can hold more than 8 electrons in their valence shells. Another key point to remember is to always mark lone pairs on the outer atoms first, and then on the central atom. In the PCl3 Lewis structure, each of the 3 outer chlorine atoms is assigned 3 lone pairs. The central phosphorus atom receives the remaining 1 lone pair, as there are only 10 lone pairs available to distribute in the structure. The current structure of PCl3 indicates that the central phosphorus atom, as well as the 3 outer chlorine atoms, all satisfy the octet rule. Now we will proceed by calculating the formal charges for each atom to determine whether this structure is stable. This is the formula we can use to calculate formal charges for the PCl3 Lewis structure. Formal charge equals valence electrons minus non-bonding electrons minus half times bonding electrons. Enter the necessary data and assign the values to calculate the formal charges for each specific atom. For phosphorus atom, valence electrons equals 5, non-bonding electrons equals 2, and bonding electrons equals 6. So, the formal charge will be equals 5 minus 2 minus half multiplied by 6, which equals 0. For each chlorine atom, valence electrons equals 7, non-bonding electrons equals 6, and bonding electrons equals 2. So, The formal charge will be equals 7 minus, 6 minus, half multiplied by 2, which equals also 0. The formal charges on the phosphorus and chlorine atoms are indicated, and it is evident that the current structure is stable, as all formal charges are 0. Therefore, this structure represents the final stable Lewis structure of PCl3. To represent a bonding pair, we draw a single line between the atoms. In this structure, one pair of electrons exists between phosphorus and each chlorine atom, so we draw one line between them. This means the final Lewis structure of PCl3 has a central phosphorus atom bonded to 3 outer chlorine atoms with single bonds. That's the Lewis structure for PCl3. If you found this video informative, press the like button, share your feedback in the comments, and subscribe to the channel for similar content.